10.5 is we're going to be trying to determine what happens to the perimeter or the area of a figure if we change the dimensions. So if we were to multiply the length by 2, or the width by 2, or the length and the width by 2, what does that do to the perimeter? What does that do to the area? Okay, that's the big kind of goal for 10.5. Again, for some of them, you're going to see this quick little shortcuts, and for others, you'll need to work it out. So before we jump right in, I'm going to skip to this very first example. Before we do, I want to make sure you understand just a basic math skill from way back and maybe in elementary school. So would you guys agree that if I were to multiply 5 times 2 times 3 times 6, that is the same thing as 3 times 5 times 2 times 6? So take your calculator right now and type in 5 times 2 times 3 times 6, or do it in your head. And what is 5 times 2 times 3 times 6? 180. Now type in your calculator 3 times parentheses 5 times 2 times 6. Okay, so now do you agree that these are the same thing? So what did I do from the first one to the second one? Dad? I just changed the order in which I was exactly. I just pulled this 3 that was right here out front. I changed the order in which I was multiplying them. The order in which you multiply numbers does not affect the answer. Multiplication order does not affect your answer. So if you believe that, then you can maybe look at the shortcuts today and understand that a little bit better. If you still don't really understand what I'm talking about here, then working it the long way may be what you have to do eventually to work the problems, okay? So, first of all, it says describe the effect of each change on the area of the given figure. So we're trying to describe the effect of the change on the area. Your answer should be things like the area would be multiplied by 2. The area would be multiplied by 7. The area would be multiplied by a half. Your answers need to be sentences on section 10.5, not just a number and a complete sentence. So you're going to describe to me what happens to the area if the height of the triangle is multiplied by 6. So first I'm going to show you the shortcut way on the board, and then I'm going to work it the long way over here on the smartboard. So what is the formula, since we're talking about area? What's the formula for area of a triangle? Area equals 1/2 base times height. Okay, what is the change that we're going to make to this figure? What does it say we're going to change? We're going to multiply the height by 6. So the shortcut is to just look at the formula. This is what the formula is originally. Now I'm going to write down A equals 1/2 B times, and instead of putting H, I'm going to put 6 times H, because we're multiplying the height by 6. Does that make sense? Okay? So then what I'm going to do is compare these two formulas to see what has happened to the area. And we just said the order in which you multiply doesn't matter. So I want this to still say 1/2 base times height. So I'm going to take this 6 and just pull it out front, so that this is 6 times 1/2 base times height. Do you agree that the order doesn't matter? So I can put that 6 in front versus in the middle, since it's just multiplication. So when you compare this formula to this formula, what happened to the area over here? It's multiplied by 6. So when it says describe the effect of each change on the area, our answer would be the area is multiplied by 6. And that would be our answer. Now, if moving that 6 out front or looking at that or even just the whole big idea makes no sense to you, I want to show you the way that will work every time if you are confused. So another option would be to actually calculate the two areas. So let's start with this picture. You told me area was 1/2 base times height. What's the base of the triangle? 12. What's the height of the triangle? 5. So what would be the area of this triangle in the picture? What is 1/2 of 12 times 5? 30. So my area would be 30 inches squared. Everybody okay with just finding the area of the triangle? Okay, now we're going to find the new area, the area of the new triangle. The area of the new triangle is still going to be 1/2 base times height, but what are we doing to the height now? Multiplying it by 6. So my height's no longer going to be 5. My height's going to be 5 times 6. What's 5 times 6? 30. Okay, so now let's plug the new height in. The base didn't change. The base is still 12. The new height is now 30. So what's our new area? 180. So then what you can do every time is you can find the original area and then find the new area, and then you can divide the area of the new divided by the area of the original. And that will tell you how many times bigger your area became. So 180 divided by 30 is what? 6. So that means the area is multiplied by 6. Questions? Here. Is that what you're asking me? How did I get to 6? So we are going to, if you want, once you find your two areas, you're trying to figure out how many times bigger did it become. So you could just look at 30 and 180 and say how many times do I multiply 30 by to get 180? Or sometimes that's not going to be a nice pretty whole number. So you can just take the area of the new shape that you got and divide it by the area of the original shape. And that'll tell you how many times bigger it is. Does that make sense? Questions? Don't be afraid to ask if you don't understand. Okay, how many people really feel like they understood the shortcut of just plugging in 6H and figuring that out? Okay, how many people feel like this was better for them to find the two areas and divide them? Okay, so again, it's just going to depend on what makes the most sense to you. We're going to work several problems because they're also going to ask us to talk about perimeter, and then we're going to make some generalized shortcuts that maybe by then the way on the board over here in blue might make more sense. Okay, but again, your answer needs to be a complete sentence where you're telling me that the area is multiplied by 6, not just a number. Okay, here's the next one. Before we go to this one though, what did we realize happened when we changed only one dimension? What impact did that have on the area? Say it again. Okay, but how? So if I multiplied one dimension by 6, what impact did it have on the overall area? It multiplied it by 6, so it had the same impact, right? Everybody see that? Okay, so now we're going to look at this one. You're going to need some graph paper, so grab some graph paper, jump up, grab some. And as soon as you get some graph paper, go ahead and graph this height. Be careful when you graph point S. Oftentimes I see students make a mistake when it's 4, 0. They accidentally graph 0, 4. And the same when you graph point U. And obviously mine's not going to look perfect because my graph was hand drawn. Make sure you have graph paper if you need it for the homework. Okay, so again, once we get this graphed, the question is still the same. It's just not printed up here. All of these examples are having the same question. Describe the effect of change on the area if, what are we multiplying by a third here? Diagonal SU. If the diagonal SU is multiplied by 1/3, what effect will it have on the area? That's the question. So again, on the whiteboard over here, I'm going to start with the formula, and we're going to look at the formula shortcut way to do it, and then we'll talk about the actual calculating the area way to do it. So here's the shortcut. Start with the formula for area of a kite. What's my formula for area of a kite? One half diagonal 1 times diagonal 2. Again, do you see how not knowing the formulas will completely sink your grade for chapter 10? You have to know your formulas. Okay, so here's our formula. This says we're doing what to what again? Okay, one of the diagonals, SU, is being multiplied by 1/3. So in my formula, I'm going to put 1/2. One of my diagonals, just pick one, is being multiplied by a third. So 1/3 times diagonal 1. And then I still have diagonal 2. Again, the order in which we multiply does not matter, right? And all of this is multiplication. So what I'm going to do is just pull this 1/3 out front and put 1/3 times 1/2 diagonal 1 times diagonal 2. So what is happening to this area formula originally to now? Okay, it's being multiplied by 1/3. So the answer would be, what happens to the area if you multiply the diagonal by 1/3? The area is multiplied by 1/3. Yeah, I'm going to show you the way to do it the long way if this didn't make sense. So we're looking at it both ways every time until I feel like everybody in the room gets it. But if you see the shortcut, you can use the shortcut. Again, how many dimensions did we change here? Just one, right? Just one diagonal. And over here, we only changed one, the height, right? So we changed one dimension here. It had the same impact on the area. We changed one dimension here. It had the same impact on the area. Does everybody see that? Huh? So we'll talk about that. We'll come back to it. We're going to come up with a generalized rule here in just a minute, okay? And if I don't answer your question, ask me again. All right, so now again, if you didn't understand this with the formula, let's actually calculate the areas and see what happens. So in this picture, what's the length of diagonal SU? Count it. What is SU? 9. Okay. And then what's the other diagonal? RT. So what's the length from R to T? Everybody agree one's 9, one's 4? Okay, and our formula is area equals 1/2 diagonal 1 times diagonal 2. And if you've got this over here on the board in blue, it's still not going to hurt us to practice calculating area because that's just going to make us memorize our formulas a little bit more. All right, what am I going to plug in for one of my diagonals? 9. What am I plugging in for the other one? 4. What's half of 9 times 4? 18. So the original kite has an area of 18 square units. Everybody okay with the original area? All right. Now what we're going to do is find the area of the new kite, which is still going to be 1/2 diagonal 1 times diagonal 2. But we're going to multiply diagonal SU by what? The diagonal SU is multiplied by a third. So now we're going to go over here and we're going to multiply SU by a third. What's 9 times 1/3? 3. We did not change RT, right? We just multiplied SU. So one of our diagonals is going to be 3 now, and the other diagonal stays 4. And what's half of 3 times 4? 6. Is everybody okay with that? Now what you have to remember if you're doing it this long way is that you're always doing the new one divided by the original one, not the other way around or you'll get the wrong answer. So you're going to do the area of the new divided by the area of the original. What was the new area? 6. And what was the first area? 18. What is 6 divided by 18 in fraction form? 1/3. And so we see that the area was multiplied by 1/3. Again, hands up if you understood it in blue over here. Good. Hands up if this makes a little more sense over here. All right. Anybody still kind of confused and have no idea how to do it one way or the other? All right. Again, your answer has to be a complete sentence. So let's see if we can make a general rule here that we could write in our notes. Each time we looked at one of these problems, how many dimensions did we change? 1. So write this down in your notes. This is your kind of general shortcut. And I don't think I have it written down anywhere in the notes, so you need to add this to your notes. If one dimension is multiplied by, and I'm going to call it A, just a variable. So instead of 6 or 1/3, if one dimension is multiplied by A, meaning some value, then the area is multiplied by what? A, the same value. So if you have a two-dimensional object and you multiply one of its dimensions by A, then the area should be multiplied by A. And that's the quick shortcut. That's the first one. We're going to learn 2 shortcuts. And if you don't understand the shortcut, every time find the original area, then do whatever it's telling you to do and find the new area. Divide the new by the old and it will tell you how many times you've multiplied your area by. Any questions before we go on? Okay, hopefully this is making sense. All right, so next directions. Notice what's changed. It says describe the effect of each change on the perimeter or circumference, which is basically the same thing because circumference still means the distance around, it's just now it's a circle. Describe the effect of each change on the perimeter or circumference and the area. So now we're going to have 2 answers on these, one for perimeter or circumference and one for area. But also notice what's happening here. It says the base and height of a rectangle with a base of 4 and a height of 5 are both doubled. So are we changing only one dimension now? No, we're going to change the base and the height. So this shortcut only applies if you are multiplying one dimension. Now we're going to multiply both dimensions. So again, I want to show you the shortcut on the board, and then I'll work it the long way, and you can decide what makes more sense. So what shape are we dealing with? Rectangle. What's my area formula for a rectangle? Base times height. This says area and perimeter, so now let's write down perimeter. What's the perimeter formula for a rectangle? Okay, you can do 2L plus 2W, but I'm going to stick with 2 base plus 2 height just because we're calling them base and height for area as well. Okay, again, we're going to look at just using the formulas first. So what are we going to do to the base according to this problem? We're going to double it. What does double mean? Multiply it by 2. So instead of having B here, I'm going to have 2B. Okay, what does it say we're going to do to the height? Same thing, we're going to double it, so that means we're going to multiply the height by 2. Okay, let's simplify that. What is 2b times 2h? 4bh. So now compare the original area to the new area. What are we multiplying the area by? 4. So when we multiplied both dimensions by 2, it multiplied the area by 4. Okay. The area is multiplied by, remember your answer has to be a complete sentence. The area is multiplied by 4. Again, I'll come back over here and work it the long way and check and make sure that makes more sense. Now let's look at perimeter. Again, we're going to double the base and double the height. So in my formula, I'm going to have 2 times, and then what are we going to plug in for b? Not 4. What are we doing? 2b. The base is doubled. So we're taking b and we're multiplying it by 2. So instead of putting b here, I'm going to put 2b. We don't know what b is, so we can't put 4. We just put 2 times whatever b was. Just like we put in 2b for b over here. Plus, the formula says 2 times, but now we're going to take the height and multiply the height by 2. So we're going to put 2h. So it said double the base and double the height. So we're going to take the letter b and multiply it by 2. Take the letter h and multiply it by 2. We already had 2's in our formula. You okay, Thad? Yes. Okay, so now let's simplify this. What's 2 times 2b? 4b. And what's 2 times 2h? 4h. Now compare this original perimeter formula to this new perimeter formula. What are we doing to the perimeter formula to get 4b plus 4h? Multiplying it by 2. Does everybody see that? So my answer here would be the perimeter is multiplied by, what is it multiplied by? 2. So when we doubled both dimensions, it had the same impact on the perimeter, but it was twice that on the area. Okay, I'm going to come over here and work it by hand, because if you're not understanding the formula idea, then it's going to make more sense if we work it by hand. We're going to check the next one, and you tell me if we can just add, okay? All right, so over here, if that made no sense, or if you're still kind of confused and you're pretty confident if you were trying to work that on your own, you wouldn't know what to do, then let's work it the long way. So the first thing we're going to do is find the area of the original rectangle, base times height. So what were the dimensions of the original rectangle? 5 and 4. Base is 4 feet. Height is 5 feet. Plug them in. Base is 4. Height is 5. What's 4 times 5? 20. That's the original area. 20 square feet. Now we're going to find the area of the new rectangle. Still base times height. But our new rectangle is not going to have dimensions of 4 and 5. What did it say to do to the base and the height? Double them. So what is 4 times 2? 8. And what's 5 times 2? 10. So now our base is 8 and our height is 10. What's 8 times 10? 80. Again, once you get your new area, you can compare and see, do you just know how many times that is? Or you can take the area of the new and divide it by the area of the original shape. Always put the new one on top. So that's going to be 80 divided by 20. What's 80 divided by 20? 4, which means the area is multiplied by 4. Is that making sense one way or the other? Okay. Now let's look at perimeter. Perimeter was 2 base plus 2 height. Using the same original shape. Base is 4. Height was 5. What's 2 times 4? 8. What's 2 times 5? 10. What's 8 plus 10? 18. So the original perimeter is 18. And now we're going to find the new perimeter, which is still 2 base plus 2 height. What's the new base? Come on, guys, don't zone out. Stay with me. What's the new base? 8. What's the new height? 10. So now we're going to have 2 times 8 plus 2 times 10. What's 2 times 8? 16. What's 2 times 10? 20. What's 16 plus 20? 36. And then remember, you're going to do perimeter of the new shape divided by perimeter of the original shape. So perimeter of the new divided by perimeter of the original. And that gives us 36 divided by 18. What's 36 divided by 18? 2. And so the perimeter is multiplied by 2. Questions? Okay. Again, how many dimensions did we change here? 2. How many dimensions were there in the formulas? When I say dimension, I mean like a different value represented in your formula. So we have a base and we have a height. So we have 2 dimensions, right? So we changed 2 dimensions, but that ended up being all of the dimensions, right? Because there's not any other ones. Okay, let's look at the next one before we make our final decision. So here's the next problem. Flip it over on the back. Now we have a circle. Again, we're going to look at the formula and see if we can see a shortcut. And this is probably the harder one. So if you think you've got it, pay close attention over here. This time, same directions. What happens to the perimeter and the area if what? What are we doing to it? Okay. The radius is being multiplied by 1/5. Okay, so before we work it, I'm going to take some guesses. What do you think is going to happen to the area if it's multiplied by 1/5? It's going to be multiplied by 1/5. Somebody think something different? What do you think is going to happen to the perimeter? The answer has to be the perimeter is multiplied by blank. What do you think is going to happen to the perimeter? It says maybe 1/10. Anybody have different answers for either area or perimeter? Okay, not to pick on Tate, but neither one of these are correct. So does anybody have a different guess? Say it again. The area is multiplied by 5 for area or perimeter. Area is multiplied by 2/5. Any other guesses? Okay, none of these are correct yet, so I'm not feeling super great yet. Let's see what we got. So I'm going to erase these answers, and let's write our formulas down. So what's the area formula for a circle? Pi r squared. Okay, and what are we going to do to the radius? Multiply it by 1/5. So instead of having r here, we're going to put 1/5 times r, and then it's still going to be squared, right? So we're replacing the letter r with what we're doing to the r. We're multiplying it by 1/5. So instead of having 1 r, we now have 1/5 r. Okay, when you have this here, the square means we have to square both the 1/5 and the r. So what is 1/5 squared? Not 2 25ths, close. 1 squared is not 2. 1/25. If you get a decimal, use your math, enter, and have it change it back to a fraction for you. 1/5 squared just means 1 squared, which is 1, and 5 squared, which is 25. Or you can type it on your calculator and change it back to a fraction. So 1/5 squared is 1/25. What's r squared? R squared, right? I guess I could put this after. So now again, it's still just all multiplied. So I'm going to bring this 1/25 out front. So this is 1/25 of pi r squared. So compare the two formulas. What did we end up multiplying the area by? 1/25. So my answer would be the area is multiplied by 1/25. And for at least the third or fourth time I've said today, your answer has to be a complete sentence. The area is multiplied by, and then what it's being multiplied by. Okay, let's check perimeter. What's my perimeter? Well, for a circle, we call that circumference. What's my circumference formula for a circle? 2 pi r. Okay, what are we doing to the radius again? Multiplying it by 1/5. So now instead of putting r, I'm going to put 1/5 r. Again, it's all multiplication, so it will not make a difference if I pull this 1/5 out front. So now I have 1/5 of 2 pi r. So what happens to the original circumference to the new circumference? It's multiplied by 1/5. So the circumference is multiplied by, Ruben, you should probably write this down, 1/5. All right, so this one was a little harder. Hands up if you really understand doing it the shortcut way with the formula. Good, all right. So let's try it over here in case we didn't understand the formula. Let's work the areas, work the circumference, and then we're going to see if we can make some just conclusions and stop working it both ways from here on out. So area, you said was pi r squared. According to the picture, what's the radius? 10. So plug it in. Pi times 10 squared. What's 10 squared? 100. So the original area would have been 100 pi. But we're going to take the radius now and we're going to multiply the radius by 1/5. So we're going to find the new area if we multiply this by 1/5. So what is 1/5 times 10? 2. 1/5 of 10. Sorry about that. Okay, 1/5 of 10 is 2. So now plug in your new radius. Pi times 2 squared. What's 2 squared? 4. So we have 4 pi. Again, be careful. Where I see a lot of students go wrong is they try to say, oh, 4 pi times 25 is 100 pi, so the area is 25 times bigger. Nope, it's new divided by old. The area of the new divided by the area of the original. So what is 4 pi over 100 pi? What happens to those pi's, first of all? They just cancel out. So what we're really asking is, what is 4 over 100? 1/25. And again, you can take your calculator, just if it gives you a decimal, put it back as a fraction. So the area was multiplied by 1/25. So if the formula is confusing you and you're like, I don't get how we're getting that, or I don't know what it's going to be, just calculate the areas. Find the area of the original one, find the area of the new one, new divided by original, here's your area. It's 1/25 the area. Write it as a complete sentence. The area is multiplied by 1/25. Okay, last one I'm going to do by hand, long way, is the circumference. So one more time, circumference is 2 pi r. What was the original radius? 10. So we have 2 times pi times 10, which gives us 20 pi. Okay, now we're going to find the new circumference. What's the new radius going to be? We took a fifth of 10 and we got 2. So now I have 2 times pi times 2, which is 4 pi. Again, don't go, oh, 4 pi times 5 is 25. That means we multiply, or is 20. That means we multiply by 5. It's new divided by old. So area of the new over the area of the original. And when you take 4 pi and divide it by 20 pi, the pi's cancel. And what's 4 over 20? 1/5. So again, the circumference is multiplied by 1/5. Now I did that fast. Questions? Okay, so back to what Tate asked. We have to come up with a second conclusion here, our second shortcut. So notice when we multiplied both dimensions by 2, what happened to the perimeter? It was multiplied by 2. So the same impact, right? Then when we multiplied both dimensions by 2, what happened to the area? Multiplied by 4. So we thought maybe we could just do 2 plus 2 is 4. But does that work over here? Is 1/5 plus 1/5 1/25? No. So what are we really doing to that value of 2 to get 4, or to that value of 1/5 to get 1/25? We're squaring it. So here's your shortcut. Write it down. This should be in your notes, but I'm going to write it on the board again separately. But it should be your next slide right here, but it's not all filled in. Well, yeah, it is. So change in dimensions. So follow me on your slide right here, or write this down if you want to. But here's what we're saying. If all dimensions are multiplied by A, so in the first example, we had a base and a height. Did we double both the base and the height? Yes. In the second one over here, what was our only dimension? The radius. So did we change all the dimensions when we multiplied the radius? That was our only dimension. The only variable we have is r. So if all of the dimensions are multiplied by A, then that means, so I'm going to write this down, if all dimensions, again, I want to make sure you understand that the word dimensions means different variables in your formula. So a base and a height are different dimensions. A radius is a dimension. A length, a width, those are all dimensions. If all dimensions are multiplied by A, again, we're just letting A be whatever that number is, 2, 1/5, 6, whatever it is. If all dimensions, not just one dimension, if all dimensions are multiplied by A, then two things happen. The perimeter or circumference is multiplied by, what's the perimeter or the circumference going to be multiplied by? Careful, we're using the letter A. So if all dimensions get multiplied by A, then what happens to the perimeter or circumference? Then they're multiplied by A. And then the next thing that happens, the area is multiplied by what? Not 2A. Remember, we found out that 1/5 times 2 is not 1/25. So what did we actually end up doing to this 2 to get 4, or this 1/5 to get 1/25? We squared it. 2 squared is 4. 1/5 squared is 1/25. So the area is multiplied by a squared. Okay, I'm going to make up a separate example that's not in your notes just to see if you're understanding the shortcut. Once you get that written down, look over here. Let's say that I have a, let's do a square. Okay, and let's say that the side is multiplied by 3. I want you to think about what happens to the perimeter and what happens to the area. Don't say it out loud, but think for just a minute. If I have a square and the side is multiplied by 3, what would you write down as a sentence for the perimeter is multiplied by blank, the area is multiplied by blank? So you're asking yourself 2 questions. First of all, am I only changing one dimension, or am I changing all of the dimensions that are in the formula? Sometimes the formula only has one dimension, so you are changing all dimensions, like the circle. Sometimes the formula has 2 dimensions, so you may only change one or you may change both. If you only change one, we don't know what happens to the perimeter. There's not a shortcut way to figure that out, but the area is multiplied by the same value. If all the dimensions get changed, the perimeter gets changed the same, and the area gets changed by that value squared. All right, somebody tell me, what do you think happens to the perimeter here? Okay, Caleb said multiply by 3. Somebody else said multiply by 3. What do you think happens to the area? Gets multiplied by 9. What's the formula for area of a square? Side squared. So what is the only dimension on our square? The side. So are we changing all the dimensions when we change the side length? Yes, because it's the only dimension that it has. So if all dimensions get changed by A, where A in this case is 3, then the perimeter or circumference will be changed by a factor of 3, and the area will be changed by a factor of 3 squared, and 3 squared is 9. So the answer here would be the perimeter is multiplied by 3, the area is multiplied by 9. Questions? Okay, truthfully, hands up if you feel like, I think I got this. Okay, this is the hard part, and some practice may be needed, but for most of you, I'm feeling good. I'm just still a little worried just because I know in the past it becomes a hard part. Okay, we're going to look at one of these questions where we have to work backwards, and let's see if you can understand this. Okay, the last 2 questions are harder, and you have to work backwards to figure them out. I'm going to try to just do it the shortcut way, though. Okay, so we're talking about a circle. A circle has a circumference of 32 pi inches. If the area is multiplied by 4, so this time they're giving us what happens to the area, and they want us to go backwards and figure out what happened to the radius. Okay, are you guys with me that that's what they're asking? So look back at your chart. They're basically telling you what the a squared value is, and they're asking you to figure out what the a value was. What happened to the dimension? If this is what happened to the area, then what happened to the dimension? So what would you have to do to this a squared in order to get a? Say it again. Square root. Is everybody with me there? If I know a squared and I want to know what is a, I'm going to have to take the square root. Okay, so over on this question, when it said the area is multiplied by 4, and again, we have to decide, are we changing one dimension or all dimensions? Because that makes a difference. If we're changing only one dimension and the area is multiplied by 4, then the dimension was multiplied by 4. But if all of the dimensions are being changed by a squared, then that means, or our area is a squared, then that means our dimension is a. So you have to think about the formula. What's the formula for a circle for area? Pi r squared. How many dimensions are in a circle then? One variable, r, right? So when you change one dimension, are you changing all the dimensions? Yes, if you change r, and that's the only dimension it has, then you've changed all the dimensions. So you're using the second shortcut, not the first one. Okay? So if the area is multiplied by 4, then they're basically giving you a squared. So we're just going to take the square root. What's the square root of 4? 2. So we would say what happens to the radius? The radius is multiplied by? One more time, what's it multiplied by? 2. So let's think about our formulas real quick. Which formulas only have one dimension so that when you change that one dimension, you're actually changing all the dimensions? So grab your formula sheet real quick and look at your area formulas. And let's list the ones that when you change one dimension, you're really changing all the dimensions, because there's a few special cases. And I'm going to list them here. When you change one dimension, you're really changing all the dimensions because it's the only one it has. So looking at your formula sheet, what's one shape that only has one variable in its formula? A circle, I heard. And then square, I heard. What else? Rectangles have two dimensions. What are the dimensions of a rectangle? Length and width, or base and height. So when you change just the base, that doesn't change all the dimensions. What other shape on your formula sheet only has one variable in it for area? Equilateral triangle. So here's the deal. Each time when you're looking at your problems, if you don't want to work them out the long way, then what you can do is ask yourself, look at the formula, start with the formula and ask yourself, am I only changing one dimension in the formula, or am I changing all the dimensions in the formula? If I'm changing all the dimensions, then whatever I do to the dimension, multiply it by 2, then the perimeter has the same impact. It's multiplied by 2. The area is multiplied by 2 squared. If it has multiple dimensions and I'm only changing one of them, then I don't know what's going to happen to the perimeter, but the area will be multiplied by that same value. So if I multiply only the base by 2, then the area is multiplied by 2. Is that making sense? Questions if you really don't understand? Okay, it may take some practice. You may need to re-watch the video to understand and hear it again, or you may need to look back through your notes again. But that is 10.5. That's the big idea. We're not going to do the last one. That's a lot harder. Questions at all? Okay, let's move on to 10.6. Last section of chapter 10. And again, I told you 10.6 is really just going to be one extra little step. We're going to talk about probability. But we need to review probability from Algebra 1 and make sure you understand what probability means. So the first thing that should be in your notes, I believe, is this slide. Is that correct? Okay, so looking at 10.6. So probability is, remember something like, if I say, what's the probability it's going to rain today? When you see the forecast, they're going to give you an answer of something like what? 10%, 5%. So probability could be a percentage. What is a percentage out of? 100. So when they say a 10% chance of rain, that is what out of 100? 10 out of 100, right? So my probability could be written, instead of a percentage, it could be written as a fraction. So your answer could be a fraction or it could be a percent. If it's a percentage, it's going to be a number that's between what and what? Say it again. Sorry, Ruben, one more time. 0 and 100, okay? So if all of a sudden you get 150%, you've done something wrong. You can't have more than 100% chance of something happening. You can't have a negative number. It's got to be 0 to 100. If it's a fraction, it's going to be between what two numbers? Not 1 and 100. 0 and 100 is our percentage, not 0 to 10. If it's 0 to 100%, and a percentage is something out of 100, what's that going to give me for my fraction? 0 to 1, right? 100 out of 100 is just 1. So my fractions are going to be 0 to 1. You can either have a 0 as your probability, or you could have a 9/10 as your probability. 9.9 out of 10. Or you could have a 1, which means 100%. So in your notes, you may want to write that down, that you're either going to have a 0 to 100%, or you're going to have a 0 to a 1 as a fraction. Okay, those are the types of answers I should see on your homework. Probability means the set of all possible outcomes, which is your sample space. Probability is going to be the number of outcomes of whatever you're looking for out of your total sample space. So we probably in algebra talked about things like if you have a bag full of marbles, and some of them are blue, and some of them are red, and some of them are green. What's the probability you stick your hand in the bag and you pull out a blue marble? Okay, do you guys remember things like that in Algebra 1? Okay, so the event would be the blue marbles, and the sample space would be all the possible marbles. Okay, but we're not going to be doing probability in the terms of algebra. We're going to be doing probability in the terms of geometry. So geometric probability is the same idea. It's just going to be that our probability, our event, is going to be something like the area of a triangle or the area of a circle. So we're going to have our event out of the total event. So example for geometry might be you have a dartboard. What's the probability that you throw a dart and you hit the bullseye? So we would need to find the area of the bullseye. That would be our event. And then what would be the total? The area of the whole dartboard. Does that make sense? Okay. And so the only thing we're doing different than what we've been doing is dividing our two areas. We've been finding areas, so that won't be anything different. Okay, so here are some examples of geometric probability. The first one goes way back to chapter 1. They may ask you to find the probability that you pick a point on line segment BC. So that means you would simply just find the distance from B to C. That would be your event. And what would be the total distance? 80. Which would be really easy. We would just be counting those distances. Does that make sense? Okay, and then our answer will either be written as a fraction or a percentage. Follow the directions. If it doesn't say, I'll accept either or. Okay? The next thing that you might be looking at is something like this, a circle. So if we're looking at this idea, how much is a full circle? 360 degrees. So if they told you that this was 30 degrees, what could you do to find the probability of the blue shaded area? Exactly. The probability of your event would be the shaded, and then you would just put 30 out of the total circle, which is 360. And then you would reduce that and either write your answer as a fraction or as a percentage. Does that make sense? Okay. And then the last example is what I just talked about with the dartboard. Our event would be the shaded area. So what would we have to calculate there? Area of the triangle. And what would we divide that by? The area of the rectangle. Okay? So probability for today is just going to be the area of whatever you're looking for out of the total area, or the degrees out of the total 360 degrees, or the distance out of the total distance. All right, and so again, I really don't think this will be too hard. We'll look at a few examples together. but it's not very difficult. This part, though, we didn't talk about. So when you told me that you might get an answer of a 10% chance of rain, what does that mean the chance of not raining is? 90%. So they may ask you, what's the probability that it does not occur? Well, you could find the probability that it does occur and then take 1 minus that, or 100 minus that. So if it was a 10% chance, 100 minus 10% is 90%. Or if it is 10%, remember that's the same as 1/10. So 1 minus 1/10 would be 9/10. So you can either write it as a fraction or as a percentage. Okay, let's work a couple of examples. I'll be super picky about one thing, and it's only because I know that when you head to Algebra 2, you're going to have to write it this way. So every time you write your answer, I want you to put probability of, and then put whatever your event is. So what do they want us to find here? A point is chosen randomly on line segment PS. Find the probability of each event. The point is on RS. So what are we trying to find? The probability of it being on RS. So what I would want to see on your paper is P parentheses and then whatever you're trying to find, RS. Does that make sense? So just put your event, whatever it is you're looking for, in your parentheses. Equals, and then you'll write it as a fraction. What you want out of the total. So what's the distance from R to S? 5. What's the total distance of the entire line segment? Good, it's going to be 5 plus 13 plus 7, which is 25. And what's 5 over 25 as a fraction? As a fraction. 1/5. Again, you can use your calculator and it'll change it to simplest fraction form for you. Or you can write that as a percentage. What is 1/5 as a percentage? What is it? Not 50. That would be 5/10 or 1/2. 20%. How do you change 1/5 to a percentage? What is 1 divided by 5? It gives it to you as a decimal. So you do 1 divided by 5, and what does it tell you as a decimal? 0.2, and then how do you change that decimal to a percentage? Multiply it by 100. So 0.2 becomes 20. So if you have a fraction, change it to a decimal, and then multiply it by 100, and that'll give you your percentage. Is everybody okay with that? Okay, and again, on the homework, I'll accept either or depending on what it asks. If it says write your answer as a fraction, do that. If it says write it as a percentage, do that. If it doesn't say, you can do both or one or the other. All right, I'm going to skip on. Actually, let's try this one. What's the probability the point is not on QR? So what's going to go in our parentheses? Nope. It didn't say find the probability of QR. It said find the probability of not QR. So we want to find the probability of not QR. So if we don't want QR, what do we want? PQ and RS. So what's the distance from PQ and RS? 12. 7 plus 5. And what's the total distance? 25. So again, it's what you want out of the total. Everybody okay with the probability idea? Okay, you can leave that if it's in simplest form. Is 12/25 in simplest fraction form? Will it reduce? Nope, nothing will go into 25 and 12. So that's my answer. Or what is that as a percentage? 48%. Are we getting the idea as far as distance goes? Okay, we need to do one more because I don't want this to mess you up when they use this word. So try this next one. Find the probability the point is on PQ or QR. PQ or QR. So that means in our parentheses we're going to have PQ or QR. So what would be our total event? 20, because it means we're finding the points either on PQ or it's also on QR. So the total possible distance would be 20. So we're going to add those together. Does that make sense? Okay. And then what's our total distance? 25. That is not simplified. What is 20 over 25? 4/5. So again, your fractions need to be simplified if you leave it as a fraction, or change it to a percentage. What's 4/5? 80%. And again, I'll accept either answer, whatever the directions say, or either answer. Are we good with that part? Okay, let's look at something different. So look at the next example. It says a pedestrian signal at a crosswalk has the following cycle. Walk for 45 seconds, don't walk for 70 seconds. The question is, what's the probability that the signal will show walk when you arrive? So one more time, you're going to start your answer with P parentheses. What's going to go in your parentheses? What are we finding the probability of? Walk. So whatever your event is goes in your parentheses. Probability of walk. All right. How much time does it flash walk? 45 seconds. So that means 45 goes on the top. What's the total amount of time? 115. Where did you get 115 from? 70 and 45 together. So be careful there. It's flashing don't walk 70 seconds, walk for 45 seconds. So the total amount of time would be 115 seconds. Okay, and what does that reduce to as a fraction? 5 over 23? 9 over 23? Somebody agree? Sounds right. 5 goes into both. So this would be my answer. Or what is that as a percentage? Okay, so it's what before you rounded? Okay, so 0.3913, which when we multiply that by 100 becomes 39.13%, or we could put approximately 39%. Watch your directions. If it says round to the nearest percent, 39. If it says round to the nearest tenth of a percent, it would be 39.1. Just follow your directions. Any questions on these kinds of problems? Okay, I'm going to skip ahead. Let's look at the circle questions. I put a lot of questions on the notes, but we're not going to do all of them, okay? So here's a circle kind of question. Again, how many degrees are in a circle? 360. All right. It says use the spinner to find the probability of each event. What's the probability that it lands on? Yellow. So what's going to go in our parentheses? Yellow. Probability of yellow equals. How much of our circle is yellow? 140 degrees. And how many degrees are in a circle? 360. So you'll just divide. Remember, a quick shortcut when you have a problem like this is if they both end in 0, your zeros can cancel. So that becomes 14 over 360, or excuse me, over 36. Sorry, 14 over 36. But that will still reduce. What does that reduce to? 7/8, or 7/18. Sorry, 7/18. Or you can write it as a percentage. What is that as a percentage? 0.38888, is that what we're saying? So that would be approximately 39%. Questions on those kind? Okay, let's see. I may do one more. Let's do, I'm going to skip the next one. How about this one? The probability the pointer does not land on green. So that's the last one on the page we're on. What's going to go in our parentheses? Not green. So what would we do to find the probability of not green? Okay, so one way to do it would be to find the probability that it does land on green and then subtract that from either 1 if you have it as a fraction or 100 if you wrote it as a percentage. So you could do 1 minus the probability that it does land on green. What would be another option? Corbin? Add all the ones that are not green. So if you don't want green, then you do want red, yellow, and blue. So what's red, yellow, and blue? So you could do 252 out of 360. What do you get if you do it that way? 70%, 7/10, or 70%. So if we did it Caleb's way, we would have 1 minus, the probability that it is green is 108 out of 360, which is going to be 1 minus, what's 108 out of 360? 30%, so that's 0.3 here, which would give us 0.7 or 70%. Questions either way you look at that? All right, let's do some area. Oh, did you have a question, Corbin? You might, yeah. So is the color an issue? Okay, so if you have a problem with your colors, just call me and say, hey, I'm having trouble. Can you tell me which one is supposed to be the blue, the red, the green, the yellow, whatever, okay? All right, so last questions are dealing with area. And I put several on here, but we're just going to work one, and then if you need more help, I can help you individually, okay? So here's this big picture. It says find the probability that a point chosen randomly inside the rectangle is in each shape round to the nearest hundredth. So notice now they are giving us directions on how to round our answers. So you're going to follow your directions. It says each shape, but then I actually gave you 3 different questions. Do you see how the first question says basically find the probability that it lands inside what? The circle. And then the next one says the trapezoid, and then the last one says one of the 2 squares. So on the first one, if we wanted to find the probability that it landed in the circle, we're not going to work this one, but let's just write down what we would need to find. So on the first example, on your notes, probability of what's going to go in parentheses? Circle. What would we need to find the probability it lands in the circle? Okay, and which one would go on top? Okay, so we would find the area of the circle, and then on the bottom would be the area of the whole shape, which is the rectangle. Questions on what I mean by doing that? Any questions? Okay, and then we would just round our answer to the nearest hundred. Okay, look at the second one in your notes, same thing. It's asking us to find the probability of the trapezoid. So we would have to find what? Okay. Area of the trapezoid. I'm just going to put area of trap over the area of the rectangle. And if you have multiple questions dealing with the same picture like this, you will have already found the rectangle, so you won't have to keep doing that every time. You'll already have the answer for that. Okay, let's do the last one together. It says the area of one of the 2, what? Squares. So we want to find the area of one of 2 squares. Now be careful with that wording. That's why I wanted to do this one. It's saying if you were basically to pick any point in this picture, what's the probability that the point was in one of these 2 squares? So basically what that's saying is, think about like a dartboard. If I were to throw my dart at this board, what's the probability that it lands here or here? And when you see that word or, you think add them together. So it could land in this square or it could land in this square, which means really you're finding the probability of both squares. And it gets confusing because they say one of the 2 squares, but that just means it could land in either one. Does that make sense? Okay, so we need to find the area of what? The area of both squares. And then we need to find what? Area of the rectangle. Okay, let's do that real quick and we'll be finished for today. How do I find the area of a square? Side squared. So write your formulas down. Side squared. How do I find the area of a rectangle? Base times height. But be careful. I don't just want one square. How many squares do I want? 2. So once I find the area of one of the squares, since they have the same dimensions, what am I going to do? Multiply it by 2 because I have 2 squares. Okay, what is the side length? 10. So I'm going to have 10 squared, and then I'm going to multiply that by 2 because I have 2 squares. What's the base of the rectangle? 50. What's the height of the rectangle? 28. So we're going to do 50 times 28 on the bottom, and we're going to do 2 times 10 squared on the top. Let's simplify that a little bit. What is 10 squared? 100. What's 100 times 2? So we have 200 over, what's 50 times 28? 1400? Okay. So again, a little quick shortcut there. If you have a 0 and a 0, those can just cancel out. So we're left with 2/14, which reduces to 1/7, but the question said to round to the nearest hundredth, so they actually want us to divide and round. So what is 1/7 as a decimal? So approximately 0.14 to the nearest hundredth if you write it as a decimal, or what is that as a percentage to the nearest hundredth? What came after the 0.14? Okay, so my percentage to the nearest hundredth would be approximately 14.28%. So I'll be lenient when I'm grading that, depending on how you interpreted the directions. If you wrote it as 0.14, that's fine. If you write it as a percentage, then 14.28%. Does that make sense? Okay. A lot of information today, but I don't feel like this part is really hard. It's the other stuff I worry about over here. So, homework that you have today will be due Friday. We have Encore tomorrow. We have Encore today. So if you know you need some help, stick around, and I'll put you in Encore. And then obviously before